some grade 5 science. An introduction as to what kilowatt is. The units that are being counted on your electrical meter are measured in kilowatt used in an hour, therefore determining our electricity bill. Kilowatt is made up of 3 components, and calculated as follow: volt times amp times power factor. There is no use giving attention to power factor to save kilowatt, but by optimizing the volt supply to the standards, prescribed minimum requirements, we can save on volt and amp. This is why we take control over the voltage and in return, take control of the electricity bill. I am sure that you are familiar with the word phrase 220 volt. This is because Eskom was supplying us with 220 volt for single phase, and 380 volt for 3-phase for many years. For demonstration purposes, I am only going to use their single phase 220 volt. Eskom's base was 220 with a tolerance of -5 and +5%. This means a maximum of 231 volt and minimum of 209 volt. So they may vary the volt, anything between the top and bottom of the range. It is logic that all consumer products must be able to work within this legal volt supply range. The IEC and SABS are the gatekeepers for all factories. They ensure that products manufactured can operate on 209 volt and 231 volt. Obviously all factory design engineers factor in a safety factor on top and bottom of this range. Safety factors are added, as product manufacturers do not want their product to fail, should the supply be 209 or 231 volt. They normally add a 20 to 30% to the design of the products. Because we pay volt times amp, by dropping the 220 volt down to the minimum of 209 volt, we can decrease as much as 10% in our electricity bills. Eskom has subsequently increased from the 220 to 230 volt, and the variation range was increased to 10% above and 10% below. So volt can be as low as 207, and as high as 253, so once again the voltage supply may vary between the highest and the lowest voltage supply. The increase from 220 volt to the 230 volt increased our electricity bill as much as 9.09%. If we add the 9% to the 10% that was from the 220 saving, there is 19% saving available for harvesting by optimizing your volt supply, and the optimization takes the voltage down to 209 volts, like in the good old days. South Africa is not the only country to increase volt from 220 to 230. The entire Europe, most of the Middle East, India, right down to Australia, and many other African countries, have moved over to the same volt supply. If product is designed to sell in the market, it is to supply all the mentioned countries, and all the Bureau of Standards will ensure the consumers are protected, and that the product could operate at the low and high range of volt supply. With the distribution box receiving the unregulated power, it obviously distributes that so-called dirty power through to your appliances, and gives your appliances a beating. What we propose: have all the dirty power first passed through our equipment, and then distribute the clean power to your appliances. What we do is, we optimize voltage to the 210 volt range. A short description with a big implication to your monthly electricity bill. We control all voltage supply to your household or business. We eliminate overvoltage, and drop down to the optimization that we like to call the Goldilocks volt supply. We manage volt from as high as 260 volt, with the new output to your house, within the optimization range. This is to protect your appliances, as well as save energy. We increase the low volt, also known as brownout, from as low as 160 volt, which we take up to the optimization voltage. The reason why we address the brownout is to protect your appliances. They must not starve with insufficient voltage. The Power Ranger gets installed at the distribution board to make sure all power passes through our unit before it reaches your household appliances. Let's take a look at the effect of overvoltage on globes for an example. A robust incandescent globe like this is designed to last 1000 hours, but should the volt supply be only 5% overvoltage, you lose 45% lifespan. That means you are buying globes for about only half the expected lifespan. We all make the choice to install energy saver globes in our homes at 3 times the price. As you install these globes, you will see that it is remarkably bright, but after 3 or 4 months you start realizing that the light has either changed color and/or has lost a lot of its luminous. So it is not as bright as when it was installed. The packaging states that the globe will last 6 times longer than robust incandescent globes, which is equal to 6000 hours. Let's be honest. Do they really last that long? 6000 hours is equal to burning a light 4 hours per night, and it will last 5 years. I am sure your experience is exactly the opposite, and that is all due to overvoltage. If overvoltage is doing this to robust and sensitive globes like this, how much more are you spending on appliances failing prematurely due to overvoltage? Here are some examples of installations, single-phase and 3-phase at different homes. You will see that it is installed at the distribution box. This is how the unit looks. It has a left and right voltage display. The left is to display the input voltage, and the right displays the outgoing voltage. The left switch switches the product on, and right switch is a bypass, therefore you can at any stage bypass the unit to test your savings. Here are a few pictures of the industrial units, and a photo of a BP filling station sign that specifically pointed out that TruEnergy is a partner to save energy. This is how the bigger unit looks like inside. Here are 2 videos of homes that are on YouTube for public to view. The videos are live demonstrations, confirming the amount of saving. The home on the left proved saving of 29.8%, and the home on the right showed a 32.9% saving. This video is where the Power Ranger was activated for saving. You can see that with the fact that both volt displays are powered. We then switch off, and switching on again with the same amount of appliances switched on. The energy usage is identified and saving is calculated. The proof of 29.8% saving was achieved. This video is showing the physical wire work, testing one circuit breaker to make sure that there is no interference of the rest of the household's power usage while testing. It is just a more clinical test to ensure that testing is done correctly. The amp and volt is shown for clients to see the raw data of saving on not only the volt, but the amp as well. The saving resulted in 32.9%. These videos can be seen on our website as well.